Hi students, in today's class we will discuss regular grammar. Right? So in the previous classes we have seen what is finite automata and what are its types and the language accepted by finite automata. You know, regular language is the language accepted by finite automata. And how do I describe this regular language? Using regular expressions. And in today's class, we will be seeing what is regular grammar. Right? We will be discussing about regular grammar. Right? And when there is a language, right, there will be a grammar. You take English, English is the language. Right? And so, if I want to form any sentence in English, right, I have to follow the grammar. Based upon this grammar rules only, I can form the sentence in my English language. Similarly, we have learned there is regular language, the corresponding grammar is regular grammar, and all this it is related with your finite automata. Right? So we see what is the definition of grammar. Grammar G is equal to VTPS. Grammar G is equal to VTPS. Right? It is a 4-tuple machine. It has 4 tuples. VTPS. V stands for variables, or I can say it is non-terminals. T is terminal, P is production, and S is your start symbol. Right? Before seeing all these tuples, right, I take a sentence. Mona ate slowly. Right? Take this as a sentence. It's a sentence. Right? And in this sentence, this is my noun. And it is verb. And this is adverb. It is adverb. Noun, verb, and adverb. Right? And you write this here. Sentence is Mona ate slowly, and noun is Mona, verb is ate, and adverb is slowly. Adverb is slowly. Right? Coming to this tuples, first I said it is variable. I can say it is variable or non-terminals. Right? These things, right? Your sentence, noun, verb, and adverb. Just the sentence, noun, verb, and adverb. It is known as variables, or I can say as non-terminals. Right? And the right hand side, right? Mona ate slowly. These are your terminals. Right? The complete thing. Right? Complete thing. Right? It is your production. Right? Complete thing is your production. Verb. Right? So production will have left hand side and right hand side. In between, I will have this simple arrow symbol. Right? So these are your productions. And what is your start symbol? Start symbol is the leftmost. Right? My first production, what I have in LHS. In the first production, what I have in the LHS is my start symbol. Start symbol is, go to first production, check the LHS. LHS in first production is your start symbol. Right? So, this is the definition of my grammar. Grammar G is equal to variable, terminal, production, and start symbol. Production is nothing but rules. Right? So, how I write my rules? Rules will have LHS and RHS separated by arrow mark. Right? And what I have in LHS is your variable or non-terminal. Right? What I have in LHS is my variable or non-terminal. Usually variables are non-terminals. It will be capital letters. and terminals it will be small letters, lowercase letters plus my digits and all my operators plus minus everything, it belongs to my terminals. I tell once again, non-terminals or variables, it is your uppercase letter, terminal is your lowercase letter plus digits and symbols, right? And start symbol is the LHS of your first production is the start symbol, right? So we can see the various grammar, right? We are having 4 types of grammar: type 0, type 1, type 2 and type 3. Type 0, type 0, phrase structure, grammar. Phase structured grammar, or I can say as type 0 grammar, right? And the corresponding language is type 1 language, right? Corresponding language is type 1 language, or I can say as recursively enumerable language. This is accepted by my Turing machine that we can study in the further modules, right? So Turing machine accepts type 1 language and the corresponding, type 0 language, and the corresponding grammar is type 0 grammar or phase structure grammar, right? And you know the definition of grammar, it is G is equal to VTPS, variable, terminal, productions and start symbol. These are the tuples in your grammar, right? And here, what is phase structured grammar? It will be in this type. Alpha tends to beta, right? It will be in this form. Alpha tends to beta. Alpha tends to beta. What is alpha? Alpha will be, how I have to form alpha? Variable, union, terminal of this. Right? Alpha I have to write as, alpha is a combination of variables and non-terminals. Right? Beta is also a combination of variables and variables and terminals, right? And you know this plus means 1 or more occurrence, and this star means 0 or more occurrence. 1 or more occurrence and 0 or more occurrence. 0 or more occurrence means null, right? Empty string is also possible, and you know how I denote my empty string using my epsilon. Right? And here in phase structured grammar, there is no restriction in the length of alpha and beta. I'll tell once again, there is no restriction in the length of alpha and beta. It should be in the form of alpha tends to beta. How I will form alpha? It is the combination of variables and terminals, right? And plus. Right? So in left hand side, alpha is in left hand side. In left hand side, I cannot have any empty string. That is, epsilon is not possible in left hand side. That is the only condition. Right? Left hand side, I cannot have epsilon. But in right hand side, I can have epsilon because variable union terminal whole star. Star means null or more occurrence. Even null is possible. Empty string, epsilon is also possible. Right? So how will I write some, if I want to write some examples, right, it is a combination of variables. How will I write my productions? Variables and terminals. Right? I told uppercase letters it is variables or non-terminal. Lowercase letter is terminal. Uppercase letter is variable or non-terminal. This is terminal. Right? I can have a combination of variables and terminals. I can have a combination of variables and terminals. Right hand side also I can have something like this. It is a combination of variables and terminals. Otherwise I can have like this also. Right there. So in right hand side empty string is possible, but in left hand side it is not possible. And you should remember No restriction in the length of alpha and beta. No restriction in the length of alpha and beta. Right? What is this grammar? Type 0 grammar or phrase structured grammar. This grammar is accepted by which machine? Turing machine. Right? And next is type 1. Type 1 grammar, it is context sensitive. Context sensitive grammar. Context sensitive grammar. Right? Here, this is also in the form of alpha tends to beta. Alpha tends to beta, but there is a condition in the length of my beta. There is a condition in the length of my beta. In phrase structure grammar, no restriction in the length of alpha and beta. Here there is a condition in the length of beta. Right? So, length of beta. How will I calculate length? Using mod. Length of beta should be greater than or equal to length of alpha. Moreover, how I should form my beta? Beta, it should be a combination of variable and terminals for plus. You can understand when I write plus, epsilon is not possible. So, in right hand side, right, beta comes in right hand side, right? So, in right hand side, I cannot have any epsilon production. Right? I cannot have any epsilon production. That is, alpha, I can't have anything like that. Right? I cannot have something like this in type 1 grammar. This is not possible. I cannot have epsilon in RHS. I cannot have epsilon in the place of beta. Right? But I can have something like this. Right? All these are possible in context sensitive grammar. Context sensitive grammar. Right? Type 1 grammar or context sensitive grammar, and the corresponding language is type 1 language. Right? And this type 1 language or context sensitive language. Right? This context sensitive language is accepted by LBA, linear bounded automata. Linear bounded automata. Right? Hope you got the difference between two. There, alpha tends to beta. No restriction in the length of alpha and beta. Only condition is epsilon I cannot have in LHS, but I can have in RHS. Here also, the form is alpha tends to beta, but there is a condition in the length of beta. Length of beta should be greater than or equal to length of alpha. Right? At the same time, how I can form beta? I can form beta using variables and terminals, but for at least one occurrence. Right? At least one occurrence. That is, I cannot have I cannot have epsilon in RHS. I cannot have epsilon in RHS. Right? Next is type 2 grammar. Type 2 grammar or context free grammar. Context free grammar. Type 2 grammar or context free grammar. Here, in type 2, the corresponding language is context free language, and it is accepted by PDA. All this LBA, PDA, Turing machine, everything we'll be learning in the next modules. Right? PDA, push down automata. Right? Push down automata accepts context free languages. Push down automata accepts context free languages. Right? Right? Context free grammar. And here the form of my production is A tends to A. Right? Otherwise I can write it A tends to alpha. Right? A tends to alpha. Till now we have seen alpha tends to beta. Alpha tends to beta. Alpha and beta, it will be combination of variables and terminals. Here in context-free grammar, the form is A tends to alpha. A, it is uppercase. So, in left-hand side, I can have only non-terminal or variable. Non-terminal or variable. That too, I can have a single non-terminal or single variable in LHS. Right? So, what about this alpha? Alpha is a combination of variables and terminals. Right, alpha is a combination of variable and terminal, but condition it is in LHS. LHS I can have a single uppercase letter. I can have like this. Right? I can have like this. Or I can have something like this. But in LHS I should have a single non-terminal. So this is my context-free grammar. This is my context-free grammar. Right. Next is type 3. Type 3, it is regular grammar. It is my regular grammar and the corresponding language is regular language, and this is accepted by my finite automata. This is accepted by my finite automata. Finite automata accepts regular language and the corresponding grammar is regular grammar. Right? Regular grammar or type 3 grammar. Type 3 grammar. And what is the condition? What is the form of this regular grammar? It is A tends to W B. Right? A tends to W B. This W is a combination of only terminals. W, how I should form W? T star. W is only terminals. W is only terminals. Right? So regular grammar, left hand side, I should have a single non-terminal. Right hand side, it starts with a terminal and ends with a non-terminal. Start with a terminal or ends with a non-terminal. Or I can have like this also. I can have like this also. Right? So what is this W? T star. W is a collection of terminals. W is a collection of terminals. I'll write some examples. As I told, epsilon, all my operators, if you have star, plus, slash, identifiers, everything, it is your terminal. Right? Small case letter, all belongs to terminals. Only the capital letter is your non-terminal or variable. Right? Your small letters, numerals, digits, identifiers, operators, everything, it comes in terminals. Right? So, I have written like this. A tends to, I can have like this. Right? As I said, A tends to WB or A tends to only W. W is terminals, collection of terminals. W is T star. You know epsilon is terminal. So, I can have like this. Right? And next, I can have which grammar it is? Regular grammar. How do you know? Left hand side I have a non-terminal. Right hand side it starts with terminal and ends with non-terminal. Starts with terminal, ends with non-terminal. Starts with terminal and ends with non-terminal. Right? So next I can have something like this. Is it correct? Yes, it's a regular grammar. Collection of only terminals. Collection of only terminals. Right? Can I have like this? Yes. Right? It's a regular grammar. Left hand side, single non-terminal. Right hand side, it starts with terminal and ends with non-terminal. So these are some examples of regular grammar. Regular grammar is type 3 grammar. or regular grammar, and a corresponding language is type 3 language or regular language. This regular language is the language accepted by my finite automata. Right? So in the next video we can discuss sums related to regular grammar.